Hi there, my name is Bella and I will be giving you today a video presentation which will focus on an activity that can be used in an early childhood setting for learning and is based around playtime. Further on in the video, I will also be discussing the nature and the development of children's mathematical and numeracy skills between the ages of birth to 8. The integration of maths and other areas of study can be really useful for children's learning as they get the ability to dabble with other forms of studying. For example, when I was in primary school, we integrated maths with sports games as well as mixing it with art, and I found that it made me appreciate how broad our learning can be. And then now that I'm a pre-service teacher, I'm really appreciating obviously the broadness of our learning, and especially putting that onto children, it would be really beneficial. A game that I can remember so clearly that I had a lot of fun with in primary school, and I'll be demonstrating for you later on, was a game in which we use either colouring blocks or Play-Doh, and it's called lightning rounds, and you use the blocks or the Play-Doh and you do addition, subtraction or multiplication equations, and you have to do them in lightning rounds. It can be in a group or it can be with a partner. It can even be with a teacher if you want to learn more or focus on your mathematical skills. And the particular age group in which this game can be targeted to would be probably from the ages of 9 to 12, which can be from grade 4 to 6. As this game may test their advanced math skills because we will be using addition, subtraction and multiplication, and it can be any numbers from 1 to 10. So laying out in front of me, I have 10 Play-Doh balls of yellow, 10 red, 10 green, 10 blue, and I also have on the side here the plus sign, the multiplication sign, and the subtraction sign. So I'll be giving you now a demo on how to play one of my favourite games. So this is how you play lightning rounds. You're able to play it with a group or you're able to play it with another individual. So firstly, you're just going to want to set out your game all in front of you, and then you're going to want to have your opponent in front of you. So I'm going to be naming myself player 1. Firstly, I'm going to choose the amount of yellow Play-Doh balls that I want to put in front of me. I'll put these aside for now. I'm going to go with 1, 2, 3, 4, 5. And then I'm also going to be choosing 5 of these ones. 1, 2, 3, 4, 5. I can move all the other ones to the side for now. So firstly, we're going to start off pretty basic. The way you play this game is set out how many of Play-Doh balls you want in front of you. You want to put the sign in between, and then you're going to play a lightning round. You're going to ask your opponent, who will be sitting in front of you, what is 5 Play-Doh balls plus 5 other ones, and then they need to get the answer, and then you will tally. For example, I will give you a demo on how to play. 5 plus 5 equals 10. 5 times 5 equals 25. 5 take away 5 equals 0. Now, the 5 times tables are probably the more easier ones you could do for this round. But for example, if you want to make it a bit more difficult, I might add a new one into the mix. I'm going to add 5 and 6. So then you would be going 5 plus 6, which comes to 11. Now, if you wanted to make this game a bit more interesting, instead of just using 2 single units of numbers, you're able to make 5 plus 5 plus 5 plus 5. And you're even able to, for example, you could remove this one here and add a subtraction sign into it just to make things a bit more difficult for your partner if you want to have some fun with it or test your advanced math skills. Now, with the game lightning rounds that my primary school teacher always told me is the point of this game is not just to have fun with your opponent, but it also allows you to memorize, especially when it comes to your timetables. It's really difficult to learn those, especially as there's so many, and it goes from 1 to 12. But especially if you're able to pick up these things really quickly and learn from memory, it will allow you to use your skills in maybe advanced formulas, as you don't need to be using your fingers as often when you move into later stages of your education. So the integration of math into other subjects makes students start to think about the real world. It also makes students start to think about why things happen, giving them a practical approach to learning and using mathematics. This integration also helps answer the common question posed by many students: when are we ever going to use this? Integration allows students to see the usefulness and importance of mathematics, which therefore enables them to develop new understanding and skills in other areas of studies. So next I'll be moving on to the discussion of how children between the ages of birth to 8 develop maths and numeracy skills. So numeracy and mathematics draw upon the same body of skills. Numeracy is not the same as mathematics, nor is an alternative to mathematics. Numeracy is an individual's capacity to identify and understand the role mathematics plays in the world, to make well-founded judgments, and to use and engage with mathematics as a constructive, concerned, and reflective citizen. So numeracy and mathematics obviously intertwine, but mathematics is the more scientific formula behind equations and everything. And children develop numeracy and math skills very early on in their life, and it can be even through the smallest use of numeracy and maths. For example, babies begin their skills through various ways. They start to predict the sequence of events, such as the running of water obviously means bath time, and this can be a very common numeracy learning ability for a child. And they also start to understand size, such as parents are big and babies can be small. And they also understand words that describe quantities like I want more, bigger, or no more, especially when it comes to food time. When children hit the age of 2, and they are toddlers now, toddlers begin to understand basic numbers such as how old they are by using their fingers, and they will show the number. They also begin reciting numbers as they copy the people around them. They will understand maths lingo, basic shapes such as triangles and squares and circles, and they will also explore measurement by filling containers and empty things. That can be mostly surrounded by numeracy, the filling containers and empty things, because they won't be looking at the numbers at that age. And once they move on to preschool, they should know how to recognise shapes, sort things in colour, count to at least 20, understand the numerals, such as 4 is FOUR, and they will also have spatial awareness at this age. And then kindergarten is kind of similar. They will count on their fingers using 2 hands, so 1, 2, 3, 4, 5, and then they move on to the next to go 6, 7, 8. And then they surely should be able to copy and draw symmetrical shapes at this age. They will be able to understand time concepts such as morning and night time, and they will follow instructions such as first, next, or now or later. So moving on to primary school, when a child is now 5 to 6 years old, they should predict what comes next in number patterns, know shape differences, count to 100 by 1s, 2s and 10s, but that could be maybe more advanced. And they should also know basic addition, create simple bar graphs, and also understanding the value of coins is a very common form of numeracy, as this is something we dabble with every day in our adult lives, and children should understand the value of it once they are children. Lastly, from the ages of 6 to 8, these would be known as the middle primary schoolers. Children should be able to work with money, know addition and subtraction, and then later on move into long division and multiplication. They are able to understand place value well enough to solve problems with decimal points involved, create a number sentence or equation from a word problem. They should also be able to start applying maths concepts to the real world, such as estimation and rounding, and also comparing numbers and their values. And also their skills in numeracy and mathematics should be well separated. Children should know at this age what the clear difference is. So you would have noticed by now that children's development of their mathematical and numeracy skills advance so much from a small time frame. From the ages of birth to when they hit the ages of 8, their math skills have varied from nothing to almost advanced skills. And from then onwards, they are able to use these skills to further develop their scientifical equations of mathematics at school, and also their everyday numeracy lives as they are going to be entering early adulthood. They are able to reflect back on these experiences that they gained as children in primary school to further move them on in their lives. As the YLF, which is the Early Years Learning Framework, argues, play provides an important context for learning where children are able to explore ideas, solve problems, make connections, and engage with others. Play-based learning plays a crucial role in development of literacy and numeracy skills, which can be very important for the child's future education. And through the use of games and classroom interaction, their skills will just develop into something great.